Today we're going to be working on solving absolute value inequalities. We're going to look at solving absolute value inequalities with a less than sign. Remember that absolute value represents a distance, like the absolute value of -5 is 5 units away from 0, and the absolute value of 5 is also 5 units away from 0. They both represent the 5 units from 0, however, they're in opposite directions. If we have an inequality symbol with a less than, it's telling me that the distance is less than 5 units from 0. So that could mean that from 0 we are going 1 unit, 2 units, 3 units, 4 units, but not quite 5 units, and it could go in either direction. So distance less than a number, you're going to end up shading between your two endpoints. If you're looking at the distance or absolute value greater than a number, then you're going greater than 5 units. It could be 6, 7, 8, 9, 10, and so on, and it could be in either direction. So if you're looking for a distance or absolute value greater than a number, then you are going to go to the outsides. To solve an absolute value inequality, we get the absolute value by itself. So to do that, we get rid of addition or subtraction outside of the absolute value symbol. Then we get rid of multiplication and division. Remember that you cannot distribute into an absolute value. Once we have gotten the absolute value by itself, then we split it into two cases, same and opposite, just like with an absolute value equation. But whenever you split it into two cases, you have to change the symbol and the sign. So you can't leave it as less than 5 and less than -5. You would have to change it to the absolute value is less than 5, and the absolute value is greater than -5. So you'd have to change the symbol along with the sign of the value of the number. Then we solve both cases and graph the solution, and you can rewrite it if you need to. So the first one we have is the absolute value of 5x minus 4 is less than 4. The absolute value is already by itself, so now I'm going to split it into two cases. I'll have 5x minus 4 is less than or equal to 4, and because it's a less than symbol, it's going to go to an and situation. 5x minus 4 is greater than or equal to -4. Now we solve both cases. Adding 4 to both sides, I get 5x is less than or equal to 8. Dividing both sides by 5, x is less than or equal to 8/5. On the second part, adding 4 to both sides, I get 5x is greater than or equal to 0. Dividing both sides by 5, I get x is greater than or equal to 0. To graph, I go greater than or equal to 0 goes in this direction, less than or equal to 8/5 goes in this direction, and I'm looking for where they overlap because it's a less than symbol, means I want an and situation. So everything in between will be shaded. On the next one, absolute value of 2x minus 1 is less than or equal to 5. Absolute value is by itself. There's nothing on the outside of the absolute value symbol, so I split it into two cases. 2x minus 1 is less than or equal to 5, and 2x minus 1 is greater than or equal to -5. Solve both cases. 2x is less than or equal to 6, so x is less than or equal to 3. On this one, 2x would be greater than or equal to -4, x would be greater than or equal to -2. Looking at that on the number line, less than or equal to 3 would go to the left, greater than or equal to 2. Negative 2 would go to the right. I'm looking for what's in between because it's a less than or equal to symbol. That tells me it should be an and situation. Four x minus 5 in absolute values is less than or equal to 3. I'm going to split it into two cases. Absolute value, sorry, I don't need the absolute value whenever I split it. So I'll have 4x minus 5 is less than or equal to 3, and 4x minus 5 is greater than or equal to negative 3. Adding 5 to both sides, I get 4x is less than or equal to 8, so x is less than or equal to 2. On the other side, I get 4x is greater than or equal to 2, so x is greater than or equal to 2/4, which is 1/2. Putting these on my number line, I've got 1/2 and 2. Less than or equal to 2 is going to go to the left. Greater than or equal to 1/2 is going to go to the right. I want a shade in between, and I know that because it's a less than or equal to symbol, and that tells me I'm looking for the and or overlap for the situation. The other problem, I have the absolute value is less than a negative number. I can't have absolute value equal a negative number, and I can't have an absolute value less than a negative number because absolute value represents a distance. So this is going to have no solution. If you don't recognize that it's supposed to be no solution, you can get that if you go ahead and solve it the way we did the others. We get 2x is less than negative 7, x would be less than negative 7/2, and then 2x is greater than 3, x would be greater than 3/2. When we go to graph that, negative 7/2, 3/2, I'm going to the right with my 3/2 and to the left with my negative 7/2. There is no overlap. And I'm looking for less than, so it tells me I should be looking for an overlap. So if you don't recognize it at first, you should be able to pick it up whenever you do the graphing for the solution. Greater than, whenever we do a greater than, we're looking at an or situation. So anytime you have greater than or equal to, it's going to be an or situation. Here, I had 2x minus 3 is greater than or equal to 5, or 2x minus 3 is less than or equal to negative 5. Solving the first one, 2x is greater than or equal to 8, x would be greater than or equal to 4. Solving the second one, 2x is less than or equal to negative 2, x would be less than or equal to negative 1. On my number line, I have negative 1 and 4. I'm going to go less than negative 1, or equal to, so I fill in the circle. And I've got negative 1 goes to the left, positive 4 goes to the right. It's an or situation, so it's okay that they go in opposite directions. Absolute value of 4x minus 5 is greater than or equal to 5. Sorry, 4x minus 3 is greater than or equal to 5. 4x minus 3 is greater than or equal to 5. Or 4x minus 3 is less than or equal to negative 5. Adding 3 to both sides, 4x is greater than or equal to 8. So x is greater than or equal to 2. Adding 3 to both sides, 4x is less than or equal to negative 2. So x is less than or equal to negative 2/4, which is negative 1/2. On my number line, I have negative 1/2, positive 2. Negative 1/2 is going to the left. Positive 2 is going to the right. It's an or situation, so it's okay to have it that way. Here I have absolute value of 3x minus 4 is greater than or equal to 2, and absolute value of 4x plus 1 is greater than or equal to negative 3. First one, I'm going to have 3x minus 4 is greater than or equal to 2, or 3x minus 4 is less than or equal to negative 2. Add 4 to both sides. 3x is greater than or equal to 6. divide both sides by 2 or by 3, and you get x is greater than or equal to 2. On the second one, adding 4 to both sides, I get 3x is less than or equal to positive 2. Dividing by 3, I get x is less than or equal to 2/3. Less than or equal to 2/3 goes off to the left. Greater than or equal to 2 goes off to the right. It's an or situation, so it's okay that they go to the outsides. For the next one, this is saying a distance is greater than or equal to a negative number. A distance is always greater than or equal to a negative number. So this would be all real numbers, many solutions, infinite solutions, however you prefer to write it. If you don't recognize that, you should recognize it when you get to the graph. 4x plus 1 is greater than or equal to negative 3, 4. 4x plus 1 is less than or equal to negative 3, or sorry, positive 3. Then we're going to subtract 1 from both sides. 4x is greater than or equal to negative 4. X would be greater than or equal to negative 1. Subtracting 1 from both sides here, I get 4x is less than or equal to 2. X is less than or equal to 2/4 or 1/2. Graphing this on the number line. Greater than or equal to negative 1 is going to go this way. Less than or equal to 1/2 is going to go this way. So it's going to end up covering the entire number line, which means it is all real numbers. Now I'm going to show you what you need to do if there's numbers in front of your absolute value symbol. If there's numbers in front of your absolute value symbol, it means that you're multiplying. Remember, we cannot distribute into the absolute value bars. So we have to get rid of it by doing the opposite operation or inverse operation, dividing by 2. That gives me 5x minus 4, still in absolute values, is less than or equal to 4. Then I can split it into my two cases. 5x minus 4 is less than or equal to 4. Since it's less than, it's an and situation. 5x minus 4 is greater than or equal to negative 4. Adding 4 to both sides, 5x is less than or equal to 8. X would be less than or equal to 8/5. Adding 4 to both sides here, I get 5x is greater than or equal to 0. Dividing both sides by 5, I get x is greater than or equal to 0. So less than or equal to 8/5 would go to the left. Greater than or equal to 0 would go to the right. It's an and situation. I'm looking for overlap, so I'll shade in between. On the second problem, I'll divide both sides by 3. Get the absolute value of 2x minus 1 is less than or equal to 5. Split into two cases. 2x minus 1 is less than or equal to 5. It's less than, so it's an and situation. 2x minus 1 is greater than or equal to negative 5. Adding 1 to both sides, I get 2x is less than or equal to 6. So x would be less than or equal to 3. Adding 1 to both sides here, I get 2x is greater than or equal to negative 4. X would be greater than or equal to negative 2. Negative 2 going greater to the right. 3 going less to the left. It's an and situation. I'm looking for what's in between. If there's something added or subtracted, then we have to get rid of that the same way, doing opposite operations. So I'll subtract 5 from both sides to get absolute value of 4x minus 5 is less than or equal to 3. Split that into two cases. 4x minus 5 is less than or equal to 3, and 4x minus 5 is greater than or equal to negative 3. Adding 5 to both sides, I get 4x is less than or equal to 8. X would be less than or equal to 2. Adding 5 to both sides here, 4x would be greater than or equal to 2. X would be greater than or equal to 2/4 or 1/2. 1/2, is here, 2 is here. Less than or equal to 2 would be to the left. Greater than or equal to 1/2 would be to the right. That's an and situation, so I'm looking for the overlap. The last problem, I'd add 4 to both sides. I get the absolute value of 2x plus 5 is less than -2. An absolute value cannot be less than a negative number, so this one will be no solution. So the key takeaways here, if the absolute value is less than a negative number, it is no solution. If the absolute value is greater than a negative number, it's all real numbers or many solutions.